This is eHobbyist Blog, a log of electronics hobbyist activities aimed at city dwellers who have limited space, limited money, and limited time. My name is Neil. Welcome. During this video, we will complete construction of the rectification and filtering board. Now that I have the boards with proper labeling done, I need to clamp the boards together because I'm going to be drilling for those leads that are thicker than the perf board holes. What I'm using for that is scrap leads, put it through perf board holes, corresponding holes on the two boards, and then crimping them with needle nose pliers. And I'm going to do that in several places, at least 3. The wire that's being used is about as thick as you can get and still fit it through the perf board holes, and the tighter the fit, the better the alignment. Having done that, we need to check individually the holes of each component. Can the components fit through the standard perf board holes, or am I going to have to drill thicker holes? And that particular 4-amp diode bridge requires a thicker hole than the normal perf board hole. I'm using a hole gauge to determine what my drill size is going to be for the 4-amp diode bridge. I'm using a rotary tool and a drilled bit, number 55, and just enlarging the holes so that the diode can fit through it. The clip-in capacitors, the leads are thicker, and here too I have to drill out the holes so that the capacitors can clip in. Using a very slow speed for the drill. Now here comes 4-amp diode bridge. Check the hole diameter with a hole gauge and drill out the holes. Check to make sure that we can fit the diode bridge in. And finally, the larger capacitor. Now I've got to drill holes for mounting. This is number 6 through holes. Prior to adding components to any project, I like to measure them. Regardless of what the capacitor says, I want to see what its actual value is. Just because a capacitor says 10,000 microfarads plus or minus 20% doesn't mean that that's what I'm holding. Every component I use, even the smaller capacitors and the diode bridges, have been tested. I cannot, however, ensure that I remember to turn on the video camera while testing every single component. And in this case, somebody forgot to turn on the camera. Don't blame me. Okay, we've tested the components. Now I want to clean off the copper side of the board, get the grease off, and make soldering easier. I'm using a pan of ice clamp and start with the diodes. Actually, I try to start with the smaller components first, because if I didn't, the larger components would just get in the way. We're using a solder flux pen and just solder through. It's not particularly easy to solder this stuff because the long strips tend to heat sink the soldering iron. So you have to hold the soldering iron a little longer than one might like. Important thing is just to get the soldering iron off that component just as soon as the solder melts. There's not much to say. This is repetitive. I'm putting a blob of solder on the soldering iron to facilitate transfer of heat. I noticed just how bad the edges of this strip board are as a result of that metal shear. Next diode bridge coming up. Apply some flux. And put a blob of solder on the soldering iron for heat transfer. The soldering iron is applied to the back and the solder itself applied to the front, and keep the soldering iron there long enough to get a good bond. I'm not sure that this vise isn't causing more trouble than it's worth. It tends to tighten up so that when it comes time to flipping it, you have to exert some pressure. But it works well enough, and I've used it for ages and ages, and it seems like a reasonable way to do this thing. There are other board clamps from Panavise, but since it's a small board, we'll use this clamp. I'm also using canned air to cool down the joint after I've soldered it. I don't want the heat to hang around too long and melt the component, particularly diodes. I don't think I have all that much problem with electrolytics. Electrolytics don't give you problems until 3 or 4 years after you've soldered them in. Crimp the edges here. If I had properly positioned the holes, I wouldn't need to crimp the edges. These are kind of like slipped-in capacitors, but just a little bit off on the distance between the holes. I'm using the hand underneath the board to steady the component while the solder is cooling. I don't want the component moving around. The canned air really isn't necessary. I just had bad experiences melting ICs in the past, and now I use canned air as a kind of a universal process for soldering things, at least things on a printed circuit board or perf board. Apply some solder, wait, and release. And cool it down. Got to put the jumpers in, and now that I remember, I'm putting the short jumper in. Insert the wire. And solder flux. And solder. Soldering each side of the jumper. And that's the best way to make perpendicular connections on strip board. It just seems to me strip board facilitates the construction of these one-off projects. At least something simple like this. If I were doing a card with more complicated electronics, as I will shortly, I probably want to build a printed circuit board or send away and have some company in China screw it up for me. It's really infuriating when we send off to get a printed circuit board built and they don't quite do it according to specification, and you can spend many hours, if not days, trying to figure out what's gone wrong. What's gone wrong is they kind of decided they really didn't have to do what your Gerber file told them to do. And we have the last capacitor for this particular card cooled down, and the first card is completed. Doesn't look too bad. Now I got to trim the leads using this wire snippers. I want to cut these things relatively close as I can get it, because I'm going to mount these boards. There are two identical boards. I'm going to mount them with a copper side facing each other. And so I don't want anything sticking out. Here comes the second board. Second board has got identical layout, except that one of these capacitors and one of the diode bridges don't need to be installed. This is the board for the internal power supply. And same deal. It's heating up the leads from behind the and this magical transition indicates that I'm not showing you every bleeping solder joint. Soldering up the last capacitor, I think, on this rectifier filter board for the internal supply. Cool it down, turn it around, and there she goes. Okay, I haven't seen any errors so far. Now I need to clean off the flux, as I do on both boards, and the next step would be to connect them and wire them in. In this video, I clamped the two rectification and filtering boards together and drilled holes to accommodate larger leads. I tested the components, and I soldered the components to each board. In the next video, we will be attaching and testing the rectification and filtering boards. If you like this video and the idea of the channel, click on the YouTube thumbs up icon. If you want to be notified as to when the next video is available, click on the YouTube subscribe button. If you want to suggest future directions or topics, make corrections to published videos, or voice your opinion on related matters, then leave a YouTube comment. If you want to see supplementary material that cannot be easily presented in video form, such as high-res graphics, files in different formats, lists of references, go to the corresponding website. Until the next time, good day.